We're going to make a quick review of what a ratio means. First of all, we want to make sure we understand what the ratio is. Once you understand, you want to ask yourself, can I actually have something to help me understand, like a picture or something that I can think of that helps me understand what a ratio is? And then third, how can I use that thinking in a way of using mathematical symbols? How can I use numerical representations to demonstrate my thinking of what a ratio is? You want to be able to say, oh, this is how this is going to be in real world situations or outside the classroom. So let's define what a ratio is. You will be comparing two things, and you might need to understand how to represent it in different ways. How can the math symbols be used to represent a ratio? And then what kind of overall problems am I going to be used to solve a ratio? And the first thing you need to understand is that ratio is just comparing two things. One way to represent your ratios, it would be using pictures like 1 horse to 3 raccoons. Using your symbols, you can represent 1 horse to 3 raccoons using 1 to 3, 1 to 3, and 1 over 3, or the value of 1 over 3. If we still continue using the ratio 1 to 3, this is the kind of world problems you might be solving. The zoo is expecting to have 18 raccoons. How many horses will the zoo have? Using the ratio of 1 to 3. You might have more than one way to find your answer, but one way to use your picture is having a horse and 3 raccoons and then counting 18 raccoons using the same ratio. For example, for every horse, you're going to be adding 3 raccoons until you get 18 raccoons. Notice I've added a horse for every 3 raccoons, another horse and 3 raccoons. So until I get the 18 raccoons. And then from there, I can use my picture and say, okay, I already have 3, 6, 9, 12, 15, 18 raccoons. Now, because that's what the problem was asking me. So now how many horses do I have? 1, 2, 3, 4, 5, 6. Now keep in mind, pictures are always very helpful at the beginning, but when you have big amounts of, or when you're talking about a big number, pictures might not always be the most helpful way. So you might have to start looking for other ways of representing your problem. We already know the answer is 6 horses. We're going to try to use another way to represent your problem without using pictures. And one other way is using a tape diagram. So what a tape diagram means, it's just you're representing the ratio 1 to 3 in a different way. So we're going to keep in mind the ratio 1 to 3. We're going to represent with one little rectangle or square, depending how you do it, to be the horse. And then the 3 raccoons is going to be represented by 3 tape diagrams. That is how you represent the ratio 1 to 3. Now, how are we going to use that to solve the problem? Well, we're going to use the information they gave us and we're going to write it. They told us that we had 18 raccoons. Remember, that was a problem. So one number can you add to every tape diagram to make it equal 18. One way you want to think is one number times 3 is going to give me 18. Okay? And you can take a few seconds to think. And for those of you who are very fast in your multiplication, you probably already know that the answer is 6. So for every tape diagram, we're going to add a value of 6. And there we can also see the answer of 6 horses. Now let's look what a ratio can be represented using symbols. We're going to use ratio tables to help us organize our information. Now your ratio table, like I said, is very helpful to organize not only your information, but it helps you to organize your thinking. So for example, we're going to start adding the information they gave us. For every 1 horse, there's 3 raccoons. What about if I added 2 horses? Then what would be how many raccoons? So that would be 6, right? Now keep in mind, we want to get to 18 raccoons. That is the goal. And the goal is to find out how many horses are there. So we can continue going to see the pattern. And once you see the pattern, you might be able to say, oh, I can see the pattern. I'm just going to continue adding, going down. If you notice, I am multiplying by 2, or I am adding 3 going this way. Or if I go down, I notice that for every time that I use a ratio, I am adding a horse. But if I also go the other way, I also notice I am also multiplying by 2. We have referred this method as if when you are multiplying by down, that's what we call the multiplicative method. And when you are going down, you're calling the additive method. So we're going to continue using our patterns, whichever method you decided to use, that works. And again, we are just following the pattern until we find the answer. And we notice that if we follow the pattern, we already found our answer. And our answer is, again, 6 horses. We have 18 raccoons. The zoo will have 6 horses. So another method that you want to use and keep in your mind as an option of possible finding your answer, you want to do the double number lines. What does the double number lines do? Again, it also helps you to visualize or to see how you can get the answer. So what we notice, it is very important that your number line has labels, okay, that you know what the top number means, what the bottom number means, and then from there, you start using the information they gave us about the ratio, which is 1 horse to 3 raccoons. So let's complete our double number line, and we're going to say for every 1 horse, for every horse, there were 3 raccoons. And then if I add 2 horses, then it has to be 6 raccoons. And again, do you notice that you start seeing the pattern? Either the additive or the multiplicative method that we have learned to use in the table. Again, you just want to have more than one choice to be able to find your answer. Which one is the one that works better for you? That is something that you have to be able to come up. All methods are good choices for you. And again, at the end, you are able to see that when you have 18 raccoons, you will need 6 horses. And finally, we want to be able to see what would be without symbols, without pictures. This is what we call 2 ratios together, which they are represented in a way that they mean that both are equal, that they both are the same. So we also call this a proportion. So what do you want to do here is you say to yourself, how can I get from 3 to 18? And the answer, you multiply by 6. And then you do the same thing on the top because we know that those are equivalent ratios. And then the answer will give you 6. Now this method is one way you can use your proportion, but there's other methods in the future you're going to be using. So I hope this helped you and be able to determine how ratios can be very useful and how you can use different methods to find your answer.